Okay, so looking at this one, lesson 3, using trigonometric ratios to find side lengths. Trigonometric ratios to find side lengths. Now, our goal is to determine the length of a known side. Okay. So these trigonometric ratios are going to be used only for right triangle. And then we're going to use either the sine, cosine, and tangent. Let's see here. When we know 2 of the 3 sides in a right triangle, we can find the third side using Pythagorean theorem. Okay? So if we know the 2 sides of a right triangle, we can find a third side. But if we only know 1 side, we can't use Pythagorean theorem. So there are 3 formulas that we can use to calculate the missing side. Sine theta, that's the ratio of opposite and hypotenuse. We'll talk about which one's opposite, which one's hypotenuse later. Cosine, we're going to use a cosine if we have adjacent and hypotenuse. And we'll talk about which one's adjacent, which one's hypotenuse. And then tangent, theta, opposite over adjacent. So before we use the formula, we have to know which one's opposite, which one's hypotenuse, which one's adjacent. Okay? So the word opposite. The word opposite means right across. Right across. Opposite means right across. And adjacent means right beside the theta. Okay? This is how I sometimes say it. So if this is your theta, over here, theta. If this is your theta, what is right across is over here, the opposite. So that's reference, where is your eyeball? I look at that and I was like, where is your eyeball? My eyeball is here, so where can I see which one's across from me? Right here. Okay. If this is my eyeball, which one is adjacent? Which one is beside? Beside would be, now I got a choice. Which one's beside my eyeball? It's either here or here. But this one, we already said that this is the hypotenuse because it's opposite to the 90-degree angle. So that leaves me adjacent to be right here. Opposite and adjacent create your 90-degree angle here. Your opposite and adjacent, that's where your 90-degree angle is formed. Take a look at this one. Where is your angle? Right there. So if this is your angle, it's called a reference angle. Where are you? Which one is opposite? If this is my eyeball, what I see across is this line. Right? And that's the opposite side. And if this is my eyeball, which one am I beside? This one right here. Opposite, adjacent, and then this one is my hypotenuse because that's opposite to our 90-degree angle. So what we're going to do in this, that's the first step, is identifying which one is opposite, which one's adjacent, which one's hypotenuse, because if we don't figure out which one is which, we won't pick the right ratio. And if we don't pick the right ratio, our answer won't be correct. Okay, so, yeah.
If you were to given that in sin theta is sin,
Yeah.
just how you this is angular.
Yeah, the theta is your angle.
Now, if you not think given that theta,
Oh, yeah.
because
For
of the theta you see, this angle you see. If you not given that theta inside,
for this one, your theta will be given for this topic.
it's constant.
Yeah. Okay. Good. So for our purpose today, our theta will be given. Okay. So from here, first triangle. What do you call this side? Hypotenuse. Hypotenuse. I'm just going to put H for hypotenuse. What do you call this side?
Adjacent.
Adjacent. Okay. What do you call this side? Opposite. Okay. This is your angle. This is your eyeball. This is where you're looking from. Hypotenuse is this one because it's always opposite to the 90-degree angle. Opposite is across your theta. Adjacent means beside your theta. Now what about this one? Here's your angle. What do you call this side?
Opposite.
Is everybody okay? This is opposite. Which one is this side?
Adjacent. Adjacent.
Adjacent because it's beside. And which one is this? Hypotenuse. Okay. So, next one. What do you call this side? Hypotenuse. What do you call this side?
Opposite.
Adjacent.
Adjacent.
Adjacent. Adjacent because it's right beside the theta. And this one is opposite. What do you call this side? Opposite. What do you call this side? Is everybody okay? Is everybody agreeing that this is hypotenuse? What do you call this side? Adjacent. This part. Oh, I haven't picked up the side. What's this one? Adjacent. Which one is this? Which one is this one? Opposite. Can I call somebody? Or would that make you nervous? Trevor, are you volunteering?
Sure.
Yeah. Well, that's automatic. Okay, good. Okay, so Trevor, tell me what, I'll point to parts and then you tell me which one it is.
Hypotenuse. Adjacent. Opposite.
Do you agree?
Yes.
Yes? Okay. Who would like to volunteer for this one?
What's this?
Very good. Who would like to volunteer for this one?
Countries.
Ange. Good. Last one. Can volunteer someone.
Moses.
Okay, yeah. Go ahead. Oh, which one's opposite?
All because you one
Opposite?
opposite, adjacent, and adjacent.
Okay. Now that exercise actually will help us determine which trig ratio we're going to use. And it's very, very, very critical to know which one is which. Okay, so now that we are familiar with the vocabulary, we can figure this out. Sine is the ratio. How many sides do you need at a time in each formula? Two. You only have two sides, right?
So you're trying to find
Opposite hypotenuse. Only two sides.
you're trying to find the other one.
No, we're going to be two sides. Yeah. And then we're going to use cosine if our equation has adjacent and hypotenuse, and then tangent if we have opposite and adjacent. Okay. I'm just going to skip that over. Yeah. I'm sorry. Oh, Ernestine. Oh, sorry. Yeah. Sorry. Yeah, we'll just focus on this one first and then we're not getting confused about what's happening. So many people use SOHCAHTOA to remember the correct combinations. So SOHCAHTOA is a short or acronym for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. Now, your question.
Tapi,
My question was, when it says sine and cosine both reside the formula, what do you mean when you say tangent, cosine?
Yeah. So those are the functions. That's the trig ratio, so trig function that we're going to use. Sine is opposite and adjacent. So when we look at your calculator, we have this function, right? Can you look for sine, cos, and tan? Right? Can you locate it? Okay. Another thing that I'm going to ask you to do as well is that because our angles are measured in different ways. But because we're talking about degrees, can you please make sure that on your calculator says degree or DEG? Look at your calculator and check. So both Abdel and I are going to check if you have any questions. If it says rad, we don't want that. If it says other things, grad, we don't want that. It has to be D, Okay, now, yeah. So looking at this, when you go to grade 12, then it's going to be in radian mode, but for now it's on degrees. Okay, everyone's on degree? Okay, can you try something for me? Okay, we're going to try to see if you are really in degree mode. Can you press sine sine 90. Sine of 90. What did you get? Sine of 90. If you got 1, then you're in the right mode. Sine 90 is 1. If you got a different one, then it's not. Okay. So let's take a look at some examples. Yours didn't say 1. Then you go sine 90.
Yeah, because yours says red. So you go to so yours is degree.
Okay, let's take a look at these two examples. Going from there. So the following examples show the use of trigonometric ratio to determine a side length. Okay, I'm going to ask you this. Can I use Pythagorean theorem for this? No, right? Because to use Pythagorean theorem, you need to have two sides to calculate the third side. We don't have two sides to calculate the third. So, the first step is to locate your angle. Where is your angle? Your angle, your theta is up here. This is your theta, 72 degrees. That's your theta. Oh, that's just, theta is a symbol for the angle. Yeah. Yeah. I remember on our first lesson, we said the size of theta are for angles. Okay. So theta is for angle. Okay. Symbol for angle. Okay, so if this is my angle, this is our angle theta. Now, what do you call this side? Hypotenuse. Okay, so far so good. What do you call this side? Adjacent, because it's beside. Okay, so we have adjacent and hypotenuse. Okay, so which trig ratio are we going to use? Cosine. I'm going to write down so, ka, toa. So adjacent and hypotenuse. Adjacent and hypotenuse. So we're going to use this one. Cos theta equals adjacent over hypotenuse. Okay. So if we follow this step, we're not gonna mess up. So it's a right triangle. We know where theta is. We've labeled the ones that are given. Okay. So the first thing is to label, pick our ratio, and then the next is to substitute. So cos of theta. Well, what's our theta? 72. 72. That's our angle, 72. Equals adjacent. Which ones are adjacent? X. Divided by hypotenuse. 29. Okay. And I want to tie it in, this trigonometry with the algebra. There is a left side must equal to the right side. How do you solve for x? How do you solve for x? Cross multiply. So this one is understood 1. We're going to cross multiply. Cross multiply. Now you're probably thinking, oh, what's cos of 72? Okay, what's cos of 72? Well, go try it onto your calculator. What's cos of 72 on your calculator?
0.30. 90.
Cos of 72 is a number. Cos of 72 is a number. Did you get 0.3090? Yes? Okay. So when you see cos of 72, that's the ratio of opposite side and a hypotenuse, which is equivalent to 0.30. So when you see cos of 72, that's just a number. That's just a value. So what we're going to do next is we're going to cross multiply. So cross multiply that. 29 cos 72 equals to 1 times x is x. Okay, have we solved for x? Is the x isolated? Yeah, x is isolated. The only thing that we're going to do next is just figure this out. 29 times cos of 72. So go ahead and type that into your calculator. Get 8.96. Did everybody get 8.96? We're just going to round it off to 2 decimal places. 8.96. So we're saying that this side x is 8.96. What unit would that be? Millimeters. Millimeters. Yes, question.
So if it was flipped around, it's different, right?
Yeah, yeah. If it's flipped around, that's a good question. That's a good question. What if the 29 is over here and the x is over there? Okay, let's see if that makes sense to us again. Okay, let's see if this makes sense to us again. What do we know about the hypotenuse in a right triangle? The longest side. So that's one of the trick that you can use to see if your answer is reasonable. So that's the trick on how you would find to see if our answer is reasonable. So this is my hypotenuse. My hypotenuse is 29 degrees. 29 millimeters. This better be less than 29. And it is. The hypotenuse should be the longest side. Okay, is that good?
Always should be the longest and opposite for
Ni- 90 degrees. 90 degrees. Oh, that's right. Okay, is that good? Take a look at example number 2. Okay. What we're going to do is we're going to locate our theta. So this is our theta. What do we call the x? Hypotenuse. What do you call the 27? What do you call the 27? Opposite. So which trig ratio are we going to use? Which one that has opposite and hypotenuse in it? Sine. Yeah, sine. Sine. Opposite, hypotenuse. Opposite, hypotenuse. Is everybody okay? We can't use cosine because we don't have the adjacent side. So sine. So sine theta, opposite over hypotenuse. Okay. So the next thing is to substitute. So sine of what? 55 degrees. Opposite is 27. Hypotenuse is x. Okay. So 27 divided by x. So what are we going to do next? We're going to cross multiply. Cross multiply. So when we cross multiply, what would that look like? X times sine of 55 equals 1 times 27, which is 27. Have we solved for x in this case? Not yet, right? So how do we now solve for x? How do we solve for x in here? Okay, x is being multiplied by sine of 55. We have to divide by sine of 55. So sine of 55 cancels each other out. So x is equals to 27 divided by sine of 55. $32.96. 22.96 feet. Now, does this make sense though? Does this make sense? Does that make sense to us? Just a quick check. Does it make sense?
Yes.
Why does it make sense?
Because we just plug in the formula when we did this kind of stuff.
The checking?
What?
Oh,
I said that it's algebra, we did this before.
yeah.
Plugging information.
Yeah, that's right. It's part of the algebra. Now, does this make sense that this, if your answer was 23.96, does that make sense?
23, no.
Why not?
Smaller, it will be smaller.
Yeah. If your answer was 23.96, it's not going to work because the hypotenuse have to be the longest side. Has to be the longest side. Okay. Can you do something for me? Do you remember verifying? Do you remember verifying? Remember? Okay. So here's what we're going to do. We're going to verify. We're going to check. How did we verify before? Left side? Left side and right side. What's on the left side? The left side is sine of 55. What's on the right side? Okay, so this is the left side and this is the right side. Are you okay? The left side of the equation is sine of 55, yes?
Yeah.
The right side is 27 divided by x, right?
Yeah.
So instead of x, I'm putting in the value. That's how we did it when we were checking, right? So, okay, type this in onto your calculator. What's sine of 55? Uh-huh. 91252 Okay, good, good. Did everybody get this?
Yes.
Yeah? Okay. Now try this one. 27 divided by 32.96.
My decimal points not
Okay.
opposite of 0 for
Which one?
opposite of 0
This one?
the 0 doesn't show on my
Okay. Did you get about equal? The left side is equal to the right side. Are they exactly equal? Almost. Almost.
Exactly.
Why are they not exactly equal?
Yeah, they are not exactly.
Leave it above this side.
Why are they're the first four are the same.
0.82.
9, 1, 7,
Around
4, 7, 5, 7. So you can see this is the same, this is the same. They're almost the same. Why are they not exactly the same?
They are very rounded, maybe.
because of the point.
Yeah, because of this part in here. Because we rounded this part off. But this is a checking for us. This is how we checked when we talked about our solving of equation. The left side has to match the right side.
If you are round it, it's possible.
Yeah, so we can just round it off to 4. Very, very close. And the reason why they're slightly off is because we rounded off our 32.96.
That is.
Yeah? Okay. What we're gonna do, I'm gonna finish off verifying this. Tomorrow, we can work in class to actually go through this. I'm not gonna assign anything for now, but I'm gonna verify this. How do you verify this part? Okay, verify. Left side and right side. What's on the left side? Cos 72. What's on the right side? It's x divided by 29. And what's x? 8.96 divided by 29. Okay, we gotta work out the left side. Right now, it's not obvious. It's not like our algebra last time that's pretty obvious. This one, are you sure they're the same? No. Well, how do you know they're equal? You gotta work it out. You gotta work it out. So go ahead and figure that out. Okay, did you get them the same? Are they equal? Yes? Yes, they are. And why are they equal? Because our answer is correct. If our answer is not correct, do you think the left side will equal the right side? No, it wouldn't. Okay? And this is a way for us to check our answer. Okay? So, I just wanted to show that to you, that those things are equal. Okay. I think what I'm going to do is I'm going to pause right here. Are there any questions? Any questions?
When you are taking your